Hi, I'm going to show you how to connect a 1300 Wi-Fi controller to a Skutt kiln. The controller is available from Tabletop Kilns in Glasgow, United Kingdom. https topkilns.com. The cost was £169 for the controller only, or £189 for the kit, which included the controller, thermocouple, and a solid-state relay, or SSR, with heatsink. I purchased an extra SSR for £15, and with shipping the total was £245, or $440 Canadian, or $312 US dollars. It took about a week to arrive here in British Columbia, Canada. Although the 1300 is used in Europe with their 230 volt system, it is designed to run with a voltage input range of 110 volts to 240 volts. No changes are required for it to run on the North American 120 volt system. Connecting the 1300 to my kiln was simple. First you connect 120 volt power, a thermocouple, and two SSRs to the controller. Then you remove the 240 power wires, the black and red wires in this picture, from the kiln's Kiln Sitter two bottom screws and route them to the SSRs. One 240 volt line to each of the number 1 terminals. Finally, you run a wire back, the white wires in this picture, from the number 2 terminal of each SSR to the Kiln Sitter. The same two bottom screws that we removed 240 volt power from. For those wanting more information, this video gives you options for the installation and explains in detail how each step of the installation works. There are 5 sections: how the Kiln Sitter works, wiring diagram, wiring mockup, actual wiring in the kiln, and a kiln firing showing the 1300 in action. A kiln sitter can be used to turn off your kiln when the clay reaches a certain temperature. A thermocouple measures the air temperature to turn off your kiln, but that is quite different than the temperature of any clay that's in your kiln. A kiln sitter does this using pyrometric cones. Each cone melts at a different temperature and is given a number based on the temperature. Here is a box of 0.4 cones. They melt at a temperature of 1945 degrees Fahrenheit or 1063 degrees centigrade, which is what you want for a bisque firing. If you want to use your kiln sitter, you will need to wire it to your 1300 controller. Otherwise, you can just bypass it. The top 2 screws are connected to your kiln elements, so you can bypass the kiln sitter by connecting the output of the 1300 to the top 2 screws of the switch. If you want to use the kiln sitter, you connect the output of the 1300 to the bottom 2 screws of the switch. The switch itself is quite simple, as shown by the one I've taken apart here. Just 2 metal plates, shown here and here, that electrically link the wiring connectors when the button is pushed. And that's the same button as here. This mechanical switch works by having a long rod move downward when the cone melts, freeing a lever to swing upwards and having this lever swing down, this little knob going through the hole here and disconnecting the lever which holds the button in. I will now demonstrate this process. First of all, the timer has to be turned on as it is a part of this mechanical switch. If the timer is turned off, the button will not engage. The timer turned on, the button will go in and stay in. Like that. After the timer is turned on, you then have to put a cone at the end of the rod so that the other end of the rod holds this lever in place. Now, once the kiln heats up so the cone bends, this lever will fall down, releasing this lever, and this little protrusion will turn off the Kiln Sitter. Now I'll remove this cone as if the cone had melted. And now the button has come back up on the switch and your kiln is turned off. Wiring the 1300 controller is simple. All the complex creation, saving, and running of the temperature and time settings of the kiln firing are done by the controller. Here we see the wire fasteners to the controller. The 120 power is connected to the neutral and line fasteners. Next, the air temperature probe, the thermocouple, is shown connected to the fasteners. The thermocouple is inserted into the side of your kiln. Next, the solid state relay, or SSR, is shown wired to the fasteners. This is the switch that sends power to your kiln elements, then turns the power off when the thermocouple signals the set temperature has been reached. The 1300 controller can power a number of these SSRs, depending on the design of your kiln. My 220 volt kiln requires 2 SSRs to switch the 2 power lines going to the kiln's elements. Although only one is shown here, most kilns have a number of elements. Mine has 4. Okay, the wire connecting the 120 volt power to the controller is now attached. No ground is necessary for the controller, but you could connect this to the chassis of whatever holder you have for the controller. The 220 volt plug is now connected to the terminal block. We use a terminal block because you'll have to pass the power over to our solid state relays in order for the controller to turn the power on and off to the Kiln Sitter and then to the elements. The element wire is now connected to the output of the switch on the Kiln Sitter. Although I'm only showing one element, the particular kiln you have can have 4 or more elements that you'll have to connect together. Power from the output is also sent to the timer, these black wires, and also to a small light on the green and yellow wires, which shows when the power is going to the elements when you're looking at the side of the Kiln Sitter. The thermocouple has now been connected. Although for the purposes of this mock-up, a regular wire has been used, a thermocouple requires a specific kind of wire, and there is polarity, plus and negative, on both the thermocouple and the controller that has to be matched. Now I have connected one of the SSRs, or solid state relays, to the controller. Notice that there is a negative to negative and positive to positive requirement. A number of these SSRs can be connected to the controller because of their low power requirements. Depending upon the design of your kiln, you may need more than 2 in order to operate your kiln. The second SSR has now been connected in parallel with the first one, so that the controller, when it switches this SSR on, it will switch this SSR on as well when power is connected to the terminals. 220 power has now been connected to the two SSRs. The gauge of the wire on my kiln should be about gauge 8 or 10 in order to power the elements. This may differ depending upon how many amps your kiln draws. Mine draws a small amount, relatively speaking, of 30 amps, but there are 60 and 80 amp kilns, which will require a much larger gauge. And the SSR in this case is rated for 40 amps. This will have to change as well. The power now is connected from the SSRs to the Kiln Sitter switch. So to review, we have 220 power to the switch. We have 120 power to the controller. The thermocouple is connected to the controller so that the temperature in the kiln can be used to switch the SSRs on when the controller wants the kiln to be hotter, and to switch them off when that temperature has been reached. So the power goes to the SSR. The switch is controlled by the 1300. The power then goes to the Kiln Sitter, and when the cone has been put in place, the power can then go to the elements, as well as the light, and to power the timer. I hope that gives you a clear indication of how the circuit diagram we've been talking about is implemented. The next thing we'll do is actually look at this wiring as it is implemented in the kiln. The next series of pictures shows the wiring of the 1300 controller into my Skutt kiln. This picture shows my kiln before any modifications. The two temperature controls are still attached. Here's the top one and the bottom one. They will be removed as the 1300 controller will adjust the temperature. Here the temperature controls have been removed. Power from the Kiln Sitter switch now goes directly to the elements as shown in the final wiring picture. Here's my metal box for the 1300. It cannot be solid metal as the Wi-Fi signal from the 1300 needs to travel to a computer to work. The 1300 does not have an external Wi-Fi antenna capability. This box is the smallest I could find to hold all the components. It is 7 by 7 by 4 inches deep. The computer components are sensitive to heat. Ceramic spacers were used to create an air passage between the kiln and the 1300 of 1 inch. There's one spacer and there's the other. The temperature within the box was measured at just over 30 degrees centigrade while the kiln was at its hottest. This is acceptable. At the bottom of the box is a switch to turn the power on to the 1300. Here are the components mounted in the box. At the bottom left is a black 120 volt wire to the 1300. Above it is the power switch shown in the previous picture. Behind this wire is a yellow wire that goes to the thermocouple in the kiln. You can just see it connected there, and there it goes out and over to the kiln. Between these two wires are the red and black wires that go to the bottom solid state relay, or SSR. So here's the black wire and the red wire. Two more red and black wires go in parallel to the top SSR. It's the black wire and the red wire. Each SSR has a heat sink to help dissipate the heat when they are in operation. One heat sink there, one heat sink here. The two large black wires connected to the two SSRs are the 220 power directly from the 220 plug. So the wires come through the conduit, and the second black wire comes from there. The two large white wires are connected to the two SSRs are the power that goes to the kiln when the 1300 turns the SSRs on. So when this switch is completed, the power goes back to the kiln. The 1300 box is connected to the Kiln Sitter with a metal conduit holding the 220 power to and from the 1300. The yellow thermocouple wire is shown connected to the thermocouple of the kiln. Another wire in parallel goes to the pyrometer so temperature can be monitored without the 1300. Here is the thermocouple sensor on the left and the Kiln Sitter cone holder on the right. This is the pyrometer. Not necessary, but I find it useful, especially to check and see if the kiln is cool enough to open without cracking in pottery. So this is the top section of the Kiln Sitter. In the bottom left, the picture, you can see the plug, which is used to connect the top elements to the Kiln Sitter's switch. Power from the Kiln Sitter in the lower section comes up along the two silver wires once this is plugged in. And connects to the two Kiln Sitter elements connected in series. Through here, through the element, to the next element below, and then back. If you wanted to, the top section of the Kiln Sitter has enough room so that it could also be used to house the 1300 if the solid metal housing was removed or changed to a perforated metal to allow the Wi-Fi signal passage. The bottom section of the Kiln Sitter also sends power to the two lower kiln elements, which are connected together in series. So the bottom section sends the power to the kiln element and then connects to the next top kiln element and then back to the sitter. The bottom section of the Kiln Sitter is where all the main wire connections are made. The bottom left has the 220 power coming in from the plug to the terminal block. So it comes in here to the terminal block, which connects to the input of the SSRs in the 1300 controller. Back through there. The white wires have the 220 output from the SSRs to the Kiln Sitter switch. So they come back and they're connected to the Kiln Sitter switch. If you did not want to use the Kiln Sitter, you could simply connect these two white wires to the top of the switch instead of the bottom, thereby bypassing the switch. So instead of connecting them here, they would connect directly to the wires going to the elements. The wiring here is shown using the switch. When the switch is on and the power output from the SSRs is on, power goes to the kiln elements via the four silver wires. So the two silver wires here go to the top box and the top elements. These two silver wires go to the bottom elements. There are two wires that go to the light on the side of the kiln, and two black wires that are connected to the timer. I hope that shows you how the wiring diagrams and the mock-up are actually connected to the kiln and helps you do the wiring in your own kiln. After the wiring from the 1300 controller to your kiln is complete, the controller turned on, and the Kiln Sitter set up and working, you will need to connect to the controller from a computer using Wi-Fi. Any computer with a browser will work, or a smartphone. I will be demonstrating using Windows 10. In the Systems tray, at the far right end of the taskbar is the notification area. Here you will see the network icon. Click on it and you will see the thermal controller. If your 1300 controller is set up correctly and within range of the computer, click on the thermal controller and choose Connect. Normally you'll be asked for a login and password found on the back of the controller. This has already been done, and once it's entered correctly you won't have to do it, so I don't have to do it this time. Now we're connected. 168.4.1 colon and then the port number 8888. This will connect us to the controller where we will be able to manage the temperature and the time settings. With the kiln connected, we can now select a schedule that I've already created. So you can see the temperature of the air in the kiln is being monitored by the controller. This is a series of temperature changes and ramps that'll go on for about 13 hours. I have observed in the past when it gets up to about here, about 900 degrees centigrade, the cone, which is at a much higher temperature, will have melted and we will have the kiln turn off. But let's just watch this. So I'll start the firing. It's hard to see this, but there'll be a little white line that shows the kiln in operation as it follows the temperature I've set. Every time the kiln turns on, this will go red, the little triangle. So the elements are being given electricity and heating up every time the red triangle goes on. Now, we'll check back in a while and see how this progresses. Now that we're about 3 hours into the kiln run, we can see that the white line is closely following the trajectory that I've set up. The kiln is sensing 124 degrees, and the temperature of the green line, where it's supposed to be, is 118. So it's going around that line. You can see that it's not directly on it, it goes up and down a little bit, but pretty well following it correctly. So at 19%, you can see it's still turning on and off. Wait for one more, there we go. So it's power to the element, keeping the temperature as close to this trajectory as we can. The kiln has now been on for about 5.5 hours, and the temperature in centigrade that has been reached is just under 400 degrees. So sensor temperature 355, target temperature 354, so pretty close. The countdown, 11 hours to go. However, it'll be less than that. As I said earlier, the cone will be shutting it off beforehand and then it'll start to cool. The cone melted and turned off the kiln, as you can see by the temperature reduction, but the controller continued to record the kiln as its temperature was decreased. Even though this run is finished, the kiln turned off a number of hours ago, and the controller, as I said, continued to record that. So it's a good record of what happened in the kiln. Thanks to Igor Belekaj of Tabletop Kilns for their idea to make this video, and Clive Tucker for lending me the Kiln Sitter parts.